Lesson 4, Identifying Proportional and Non-Proportional Relationships in Tables. Classwork. Example, which team will win the race? You have decided to walk a long-distance race. There are two teams that you can join. Team A walks at a constant rate of 2.5 miles per hour. Team B walks 4 miles the first hour and then 2 miles per hour after that. Create a table for each team showing the distance that would be walked for times 1, 2, 3, 4, 5, and 6 hours. Using your tables, answer the questions that follow. So we need to go ahead and fill in Team A and Team B, and we need to put our times where they belong in the time section for each of these teams. Then we're going to go ahead and go through and we're going to answer question A, B, C, D, E, F, and G. Now I know this is a lot, but that's okay. I'm going to give you guys about 9 minutes to work on this. And this is what we're going to call share and compare. So let's talk about what share and compare is. So share and compare, we're going to start off by working individually. So everyone's going to work by themselves at first to find all the problems, to solve all the problems and work on this worksheet. After we work individually, you're going to do your best to answer all the questions while we're working by ourselves. Work really hard. Use your time productively. That's one of my classroom expectations. After the time is up, we are going to pass your work to the person across from you. So the person on the across the table from you. The person across the table from you is then going to correct the work that they were given silently. They're going to look over all the answers and correct them. And then they're going to pass back the papers and review. After all this is done, I'm going to call on some people to share their answers. So be ready to share after this is all done. And we call this share and compare. So first thing that we need to do is create the table. And we're looking at times of 1, 2, 3, 4, 5, and 6. So we can fill those in for both of our tables. So we know that we're looking at times 1, 2, 3, 4, 5, and 6 hours. And that's for both sides. Now, I'm interested in the distance. Well, if we look at Team A, we know Team A walks at a constant rate of 2.5 miles per hour. Now, 2.5 miles per hour is a unit rate. We're talking about how far someone's going per 1 hour. So we know that the first distance is going to be 2.5. And then if he walks for another hour, that's another 2.5, which becomes 5 miles. Then we get 7.5, 10, 12.5, and 15 miles. Now let's take a look at Team B. Team B walks 4 miles the first hour, so we can fill that in, 4 miles. And then 2 miles per hour after that. So here we go. Here's another unit rate, 2 miles per hour after that. So the first one starts off as 4, and then we add 2 more to get 6. And another hour goes by, and he walks 8. Another hour goes by, 10. Another hour goes by, 12, and so on. For which team is distance proportional to time? Explain your reasoning. Well, let's take a look at Team B first. We know that to go from 1 to 4, we have to multiply by 4. Or we can do times 4, or we can do the ratio of 4 over 1, which gives us 4. Now we know that for it to be proportional, all of these ratios must be the same. Well, we can do this ratio too. 6 over 2, it's going to give us 3. Well, we already have two numbers that aren't the same, so we know that this one here is not proportional. Let's check this other one over here. So we know that to go from 1 to 2.5, we have to multiply by 2.5. And now, since we know the first one, we can check all the rest of them. For this to be proportional, we know that this multiplying by 2.5 has to match up with all of these. 2 times 2.5 gives us 5. 3 times 2.5 gives us 7.5. 4 times 2.5 gives us 10. 5 times 2.5 gives us 12.5. And 6 times 2.5 gives us 15. So, we can say Team A Team A's, let's do a little A's, distance is proportional to the time. Because, my favorite word, oops, I always misspell because, B-E-C-A-U-S-E, because the time, or the distance, is 2.5 times the time. And that would answer that first question. So we know that we multiply by the same constant of proportionality. For part B, we need to explain how you know the distance for the other team is not proportional to the time. Well, we know this because the ratio of 4 miles per 1 hour is 4, and the ratio of 6 miles per 2 hours is 3. So the ratios are not equal. And we solve for those two up top. 4 over 1 is equal to 4. 6 over 2 is equal to 3. Part C. At what distance in the race would it be better to be on Team B than Team A? So let's go back and look at our chart. We want to figure out, when is Team B further than Team A? So it looks like at distance 4 miles, they only do that in 1 hour, and they only went 2.5 miles. And then also 6 miles, they did that in 2 hours, whereas the other team only went 5. Oh, also here at 8 miles, they're still ahead. They're only at 7.5 miles at 3 hours. And then it looks like they match up at 4 hours, where they're both 10. So which one would it be better to be on, Team B than Team A? Well, it would be better to be on Team B if the race is shorter. The race is shorter than 10 miles. Now, if we look back at 10 miles, they both get to 10 miles at 4 hours. But before that, Team B is always ahead of Team A every hour. So that's why we picked as long as you're before 10 hours, or 10 miles, excuse me, sorry. If the members on each team walked for 10 hours, how far would each member walk on each team? So let's take a look at our chart. We know that on this chart it increases by 2.5 every time. So we'll take 10 hours and multiply that by 2.5. And we get 25 miles. And that's Team A. Now for Team B, we're going to have to take a look back. Team B, they start out at 4 and then increase by 2 every time. So it goes, oh, excuse me. Let me show you guys. So we start out at 4 and increase by 2 every time. So we get 14, and then 7 would be 16, 8 would be 18, 9 would be 20, and 10 would be 22. So we know Team B was going to go 22 miles. Will there always be a winning team no matter what length of the course? Why or why not? Well, let's go take a look. So if we look here, if our distance is 4 miles, this Team B beats them. Team B still wins here. There's 6 miles at only 5 in 2 hours. At 8 miles, they're still ahead of Team A, Team B. Now, here's the thing though. At 4 hours, Team B is at 10 miles, and Team A is also at 10 miles. So they meet up. So if the race was 10 miles long, they would both complete it in 4 hours. So will there always be a winner? No matter what length of the course? No. If the course is 10 miles long, both teams will complete the course, in 4 hours. Which means a tie, so it's going to be a tie. If the race is 12 miles long, which team should you choose to be on if you wish to win? Why would you choose this team? Well, let's take a look. So we know at 10 miles, the two teams meet up. But then after 10 miles, Team A keeps going ahead, whereas Team B keeps falling behind. So if I were to pick a team, I would pick Team A because they are faster after 10 miles. How much sooner would you finish on that team compared to the other team? Well, to do that, we need to figure out how long it takes each team to get 12 miles. So let's go back and take a look. So we know that this team moves at a rate of 2.5 miles per hour, and the other team starts out at 4 miles and gets to 12 in 5 hours. So Team B completes the 12 miles in 5 hours. Now, I'm interested in Team A. I know that Team A goes 2.5 miles per hour, and I want to figure out how long it's going to take them to go 12 miles. So what I can do is I can take my 12 miles and divide that by how fast they're going, 2.5 miles per hour. And what this will tell me is this will tell me how long it's going to take them. So when I do that, I do 12 divided by 2.5, and this is where having a calculator comes in handy. I get 4.8 hours. So that's for Team A. So Team A does it in 4.8. Team B, it takes them 5 hours. So Team A would win.